Welcome to the next session. In the last session, we have discussed about function and I have told you the functions are very important aspect because whatever we will proceed further in our subsequent text, that will happen with the function. For example, look at the slide. The first stage is what? We will find out the limit of a function, right? In the next some slides, we will calculate or we will find out the derivatives of a function. Then we will calculate the integrals of a function. So functions play a very prominent role in your subsequent text. Now, in the next lecture, we will calculate the limit of a function. So before understanding the concept of the limit mathematically, let us take it by a practical example. Say if I draw a line, right, and this is a point x is equals to 3. Look at here carefully. If you are standing just on this point x is equals to 3, for example, and someone calls you, where are you? Your answer will be, I am exactly at the point 3, because you are exactly standing at the point x is equals to 3. This is your exact answer, right? Take another case. If someone is standing, for example, this is point 3. Someone is standing very near to the point x is equals to 3 from its left, as well as very near to the point x is equals to 3 from its right. If a person is standing at this position or at this position, yani from the left of the point x is equals to 3 or from the right of the point x is equals to 3, then what will be his answer? He will not say that I am exactly at the point x is equals to 3. Rather, he will say that I am nearby to the point x is equals to 3. Or another word he or she can use, I am approaching to the point x is equals to 3. Right? So this practical situation, if you are standing as nearer as you can to a destination from its left or is from right, but not exactly at the destination, your answer will be, I am approaching to my destination. These approaching situations are mathematically represented by the concept of the limit, right? Look at here, when all values of x, so this is the point 3. If you are left to the 3, all the values of x will be less than 3. If you are right to the 3, all the values of x will be greater than 3. This you know from your early classes. When all values of x are less than 3 and becomes closer and closer to 3, we say that x tends to 3 from left and express it as x tends to minus 3. What does it mean? This is the point x is equals to 3. You are somewhere very nearer from the left to the point x is equals to 3. So when you will move nearer and nearer to x is equals to 3 from its left, we are calling it as we are approaching to the point x tends to 3 from its left, and we will write it mathematically x tends to 3 negative. Negative means the values our position is before 3. All the values at the left hand side of 3 will be less than 3. Similarly, the same happens when you are approaching towards the point 3 from its right. As nearer as you can to what is your answer? You will also say that I am approaching towards the point x is equals to 3 from its right. So if you are approaching towards a point x is equals to 3 as nearer as you can from the point x is equals to 3, then we will represent it mathematically as x tends to 3 positive. So we will use two terms for such. Either we read it as x tends to 3 minus, or we are approaching to 3 from its left hand side. This is what x tends to 3 plus. 3 plus means we are approaching to the point x is equals to 3 from its right hand side. So these two terms are very important. X tends to a, x tends to 3 and x approaches to a. Take this case, same. If x is a variable, a is a constant, x assumes values nearer and nearer to a but never equal to a, then we say that x tends to a or x approaches to a, and it is simply expressed as x tends to 3. And x tends to 3 means what? You are approaching nearer and nearer to the point 3 from its right as well as from its left. Then we will say that we are approaching towards the point x is equals to 3. So this is called a limiting position of the variable x. And here x is not equals to 3, but x can be as nearer as to 3 from its left as well as from its right. Right? This is how we can interpret the concept. Now let us take the basic definition. Let fx be a function and x tends to a, right? X tends to a means x can be nearer and nearer as it can be to a from its left as well as from its right. Then fx approaches to a real number L, then L is called the limit of a function fx as x approaches to a. And we write it as like this: limit x tends to 3, limit x tends to a, f of x is equals to L. This is how we write like this. This means what? Whenever this x will move towards a as nearer as it can be, then the value of fx will move nearer and nearer to L. And we write it like this: limit x tends to fx is equals to L. And this is how we read any limit of a function fx is L if x tends to a. Let us try to understand this by this suitable example, right? See, take the equation f of x is equals to 3, right? See, if f of x is equals to 3, suppose x approaches to 5. So what does it mean? See, this is the point 5, right? X is equals to 5. X approaches from 5 means x can approach 5 as nearer as it can be from its left as well as from its right. But it can never overlap on the point x is equals to 5. Be careful. Here, if we put x is equals to 5, see what will happen. Fx is, x minus 3. Fx is x minus 3. This is given. If x is 5, then what is the value of fx? Fx is 5 minus 3, that is 2, right? So what we obtain here for this function, if the value of x is 2, then the value of the function fx is 2. And we are giving input as 5, x is equals to 5, and the output we are getting as 2. So for x is equals to 5, fx is 2. This is the exact value. Now, what is our objective now? We will try to achieve the same value using the concept of the limit. Let us consider the values of fx by taking the values of x slightly less than 5. Slightly less than 5 means this is the point 5, right? All the values of 5 at the left will be less than 5. We are starting here from 4.9. For example, this is the point 4.9. After this point 4.99, then move further 4.999. In this way, we can move as nearer as we can move to the point x is equals to 5. So look at this table. If x is 4.9, the value of fx is 1.9. Here see, if x is x minus 3 and if x is 4.9, so put here 4.9, this means what? 4.9 minus 3, what is left? 1.9, right? So this value you can calculate. yourself, right? It may be error. If x is 4.9, put here 4.9. Then this is 1.9. If fx is this, this is, if x is this, fx is this, x is this, fx is this, x is this, fx is this. So what I want to explain in this example by taking the different values of x and fx. Actually, look at this. 4.9, then 4.99, then 4.999, again 4.9999, 4 times 9. It means we are approaching nearer and nearer to the point 5 as we can. So as x is reaching nearer and nearer to the point 5, look at here fx. Fx is reaching 1.9, 1.99, 1.999 and 1.9999. Where fx is reaching? Guess. Fx is reaching towards 2. It is the same thing. If x is 5, fx is 2. So what does it mean? This is what we want to show you. If you are moving towards the point x is equals to 5 from its left. If we are moving towards the point x is equals to 5 from its left, as nearer as we can, the function fx moves towards the value 2, right? Similarly, if we are moving from the right, these values are greater than 5. So take this as 5 point, for example, 1. This is 5.1, move ahead. 5.01, move ahead more. 5.01, 5.001. This means what? As we are moving nearer and nearer to the point 5 from its right hand side, look at the values of fx. 2.1, 2.01, 2.01, 2.0001. So where fx is moving towards 2 again. So what we observe from this example? You can think and observe. If we have a point x is equals to 5, we are moving towards the point x is equals to 5 from its right as nearer as we can, or from its left as nearer as we can, the function fx is moving towards the value 2, right? So how we will write this whole calculation or tabular representation mathematically? From the above table, it is clear that, look at this, fx approaches to 2, not exactly equals to 2, because x itself is not exactly equals to 5. X is approaching towards the point 5. Fx is approaching towards 2 as x approaches towards 5, right? So this can be written mathematically like this. Limit x tends to 5 f of x. This is our function. Function is what? X minus 3. So limit x tends to 5, x minus 3 is equals to 2. So what we concluded from this example, if we take fx is equals to x minus 3, and if x is 5 exactly, then fx is 2. And in the same calculation, in limiting case, if x is tending to the point 5, then fx is also tending towards the point 2. So in both situations, we are getting the same values. This is how the concept of limit is being explained, and how we will read it. The limit of a function fx is equals to 2 if x approaches to 5. Right? So this is all about limit. What is the next? Look at here the two ways of arriving at the limit. One by taking the values of x is less than a number, 1 or 2 or 3. The other way, the values of x is taking more than the number 1, 2 or 3. This way is known as the left hand limit. If we are moving from the left, we will call it as a left limit. If we are moving from the right, this is called the left limit, and this is called the right limit. Okay, left limit and right limit is what? If we are approaching towards the required point from its left hand side, we will call it as a left limit, and we will denote it like this: limit x tends to a negative f of x. And if we are moving from the right, then how we will write it? We will represent it limit x tends to a positive f of x. So this is called as a left hand limit, and this is called as the right hand limit, right? Are you getting the difference between left hand and right hand limit? The difference between left hand and right hand limit is what? If you are approaching to your required point, that is this, any point x is equals to 5, for example, as we have taken earlier. If you are moving towards the point x is equals to 5, are approaching towards the points x is equals to 5 from its left hand side, we will call it as a left hand limit. And on the same way, if you are approaching towards the point x is equals to 5 from its right hand side, then we will call it as a right hand limit. Left hand limit is being represented like this: x tends to a minus f of x, we will call it as a left hand limit. X tends to a plus f of x, we will call it as right hand limit. When the limit exists, when the left hand limit, existence of limit is what? When the left hand limit equals to the right hand limit. Yani the limit calculated by left hand and the limit calculated by right hand both are equal, then we will say that the limit of a function exists. What else value you will get, that will be called as the value of the limit. This means if a function fx is said to have a limiting value L, yani the function itself will have L as its limit as x tends to a. If fx approaches to L, we write it mathematically as limit x tends to a. Oh, sorry, this is a. This is all a. Limit x tends to a. Sorry, change it. This is limit x tends to a negative f of x is equals to limit x tends to a positive f of x. This is equals to limit x tends to a f of x, right? And this is the left hand limit, this is the right hand limit, both should be equal. Then we will write it as this is what? Limit x tends to a f of x is equals to L. Yani L is called the limit of a function fx if x approaches to a value a, right? This is how we can calculate the left hand and right hand limit both. After this, we will come to some questions based on the limit. So before proceeding some questions, let us have some basic results based on the limit. To some standard results on limit, these results are very frequently used during the solutions of the numerical questions, right? So you should keep in mind what is the result 1. This means what? Limit x tends to a, c is equals to c. C is what? C is any constant. And if you are operating a limit on any constant means any number, the number never changes, right? Limit x tends to 5. Malia, I have taken here 15, so it will remain 15 because limit acts on the variables, it never acts on the constant, right? So limit x tends to a of any constant c will remain the c itself. This is what if you have two functions, actually functions behave like numbers. Like numbers means the numbers directly follow the 4 fundamental operations of arithmetic: addition, subtraction, multiplication and division. So functions behave like numbers means the functions also follow these 4 operations of arithmetic. If there are two functions, they can be added, they can be subtracted, they can be multiplied, or even they can be divided, right? So if two functions are there, say one function is fx and second function is gx, if two functions are added together and you want to find out its limit, then its limit can be calculated by what? By calculating their limits separately. That is, limit x tends to a f of x plus limit x tends to a g of x, right? For example, take this limit x tends to 5. If I have taken this x square plus 3x, so this is function 1, this is function 2. So this can be written as limit x tends to 5 x square, first function, plus limit x tends to 5 second function. Not only two, if there are more than two functions are added together and you want to calculate their limit in combined form, this combined form limit can be calculated by calculating the limits of each functions. Okay, no problem. So similarly, if two functions are subtracted, right? If fx and gx are two functions and the difference of these two is given to you, then the limit of the difference of the two functions is always equals to limit of the first function minus limit of the second function. In a similar way, say I am using here the minus sign. So limit x tends to 5 x square minus 3x. This is function 1, this is function 2. So this is equals to limit x tends to 5 x square minus limit x tends to 5 of 3x. So addition and subtraction works on the similar principles. Now what will happen if two functions are multiplied together? So if fx and gx are two different functions, they are multiplied together, we can also find out the limit of the product. The limit of the product of two functions is always equals to limit of their product independently. Yani, if two functions are multiplied together, to find out the limit of the product, we can find out the limit of each function separately and they are multiplied together. Means, say limit x tends to, for example, 5. I have taken here x square log x, for example this. So x square is first function, log x is second function. So this will be equals to what? Limit x tends to 5 x square, first function, into limit x tends to 5 of log x, that is second function, right? The next, if two functions are divided, we will use all the four operations of arithmetic. If a function is divided by any other function, limit x tends to a f of x upon gx, this is always equals to limit x tends to a fx numerator upon limit x tends to a upon limit x tends to a gx, that is denominator, provided by the limit x tends to a of the denominator should not be equals to 0. Because if this will be 0, then anything upon 0 you will get an undefined quantity. Limit x tends to a c of f of x. So limit x tends to a c of f of x means what? C is any constant. And if a function is being multiplied by any number, then there is no impact of the limit on the number. Number will remain as it is. Limit x tends to a c of f of x is equals to o. This is c. This is c of limit x tends to, you can write it like this. Limit x tends to a c f of x. C is a constant. This c can be taken outside. I have told you by property 1, limit has no impact on the numbers. This will be equals to limit x tends to a f of x, right? So besides these properties, these are the one or two formulas you should also remember, because these formulas can be used in any question in any particular situation. The first formula is what? If mod of x is less than 1, you know the mod, we will discuss later. Mod is a function, mod of x is equals to x if x is greater or equals to 0, and it is minus x if x is less than 0. This is also a function. Any modulus is a function which can be defined in this way. Mod of x will remain x itself if the value of x is 0 or above. more than 0, and it get converted to minus times of x if the value of x is less than 0. So this expression is known as binomial this is a very famous expansion. This is known as binomial expansion, right? So you should keep in mind, we can use this binomial expansion 1 plus x raised to the power n. This is equals to 1 plus nx, this n comes here, plus n minus 1 upon factorial 2x square, n minus 1 n minus 2 upon factorial 3x cube, and then so on. Factorial, you know, factorial of, for example, 3, this is equals to what? 1 into 2 into 3, right? Factorial of 5, this is equals to what? 1 into 2 into 3 into 4 into 5. So factorial of any number is what? We will multiply the number from 1 to that number. The product of all those numbers will be represented by factorial. And then this is the very famous formula of e raised to the power x. E raised to the power x can be written as 1 plus x square by factorial 2 plus x cube by factorial 3 plus xn by factorial n, and then so on. And finally e raised to the power minus x. The difference in these two formulas are only what? They are having alternate sign, 1 minus x plus minus plus minus. So after having all these basic properties and formulas which you should keep in your mind, we can use any one of these properties or these formulas in any question and any particular situation. I think we should stop it here, and we will continue in the next lecture, the next topic, that is differentiation and its applications. Thank you very much.